It says the Curiosity rover landed on Mars. As it approached the surface, a descent rocket was fired to help him slow down. Please, you need to read these questions nicely. Draw a free body diagram of the rover while it was descending and slowing down. So it's moving down, its velocity is down, but it's slowing down. So which way is its acceleration? I'm going to say it again. You need to focus, otherwise, you're not going to get any of the lift questions right either. It says it's moving down and it's slowing down. So if I'm walking this way and I'm slowing down, which way is the force pushing me? That way. If I'm slowing down, which way is my acceleration therefore? That way. So please, if I'm slowing down, it means the force is acting in the opposite direction, the net force, which means my acceleration is in the opposite direction. So they're telling you that this rover is moving down and slowing down. So which way is the acceleration? Upwards. Again, that's all you need to think about for all of Newton's questions. If acceleration is up, we know that F net is which direction? So which way is the winning force going to be? Up. So all you have to do when you're drawing that, so they want a free body diagram on the rover while it is descending and slowing down. So what are you going to draw? There's no mark allocation there. What's the first force that you, again, cannot escape from? Force of gravity. It's not Fg Earth, though it's going to be Fg Mars, but it doesn't matter. It's still Fg. Then? Okay, because the descent rocket is, the force is going to be acting upwards because it's making him slow down. So this is going to be F descent rocket. So if you figure this out before you start drawing your free body diagram, you can't get them wrong. Because then you, and they again said relative sizes must be shown. So how many marks would this count? 3 marks.
So now which one is F descent rocket a bigger force?
Yeah, because the upward force must be winning. Because it's slowing down. If FG was winning, he's accelerating downwards and he's going to hit the floor pretty hard. Think about it logically as well. And this is exactly what we're going to do when we're looking at lifts.
When you say lifts isn't like elevator.
Yes. But it doesn't have to be an elevator. It could be anything that lifts things up. So it could be they can use it in the industry when they are lifting up those people in those what are they called? Cranes. It could be a crane. It could be anything that lifts something else. So it doesn't have to be an elevator. Okay, so you'll see if you look at old papers, the typical question says, Pity is standing in the lift on a scale. And he sees a reading on the scale. So I don't know why Pity is standing on a lift on a scale. So they're killing those questions. They're not asking it anymore because it really makes no sense. Who goes and stands on a scale in a lift? They're making it more realistic, yes. I am recording. Just double check. Okay, so guys, so when you get a question for lifts, again, there's going to be forces and accelerations. So your first job is to write down F net equals MA. Then you need to decide which direction is my acceleration. If my acceleration is upwards, which force is going to win? Oh, the upward or the downward force. You don't have to be specific. The upward force. If the acceleration is down, which force is winning? The downward force. If acceleration is 0, which force is winning? Yeah, they're not winning. F up equals F down. Please don't forget that. Remember, this is what we did in chapter 1. And often this gets asked and then people forget about that. So this is, we go back to Newton 1. No net force acting on the object, no acceleration. So this is what you need to decide for the lift problems. Doesn't matter if it's something inside the lift, outside the lift, the whole lift, doesn't matter. We are still going to do this. I think we must, you guys are tired again. Oh, I think we need to do a lift.